Well, welcome. In this video, we're going to be looking at the binomial theorem. Now, I know that this binomial theorem in the box looks extremely confusing, and it's not meant to be. We're going to take some time to look at that and understand what each part represents. Because it's not necessary for you to memorize the actual formula that you see in this box, but it is necessary for us to memorize the process that it's trying to explain to us. So let's start by looking at what we're dealing with. So again, we're dealing with binomials being raised to some exponent. And what this theorem does is this helps us expand out that binomial to a polynomial without actually having to go through and multiply that binomial times itself so many times. Like for example, in a minute we're going to be looking at this example, the x plus y to the fourth power. By using this binomial theorem, it's going to allow us to get to that expanded polynomial without actually having to take x plus y times x plus y times x plus y times x plus y. So let's first look at how we come up with the coefficients. The coefficients are going to be found by taking and using what we've been talking about with combinations, n choose r. Now, the first term is found by taking n choose 0. And the second term, the coefficient, would be found by taking n choose 1. And the next one would be n choose 2 and n choose 3 and so on. Now let's look at the x's. The x's are going to start with the degree of the polynomial. Whatever the degree of, the degree of the polynomial, when we're dealing with the x plus y to the nth power, that nth power is the degree. So the first term is going to be x to whatever the nth power is. And the y value would be raised to the 0 power, which is just going to be 1. Now, when you look at the next term, the x value is decreasing. And the way that we represent that is going to be x to the n minus 1. So, for example, if we had x plus y to the 8th power, well, my first term, I would have x to the 8th power. My second term then would be x to the 7th, and then would be x to the 6th, and x to the 5th, and so on. So the way that we write that, like we said, is x to the n minus 1. So 8 minus 1 would be 7. Looking at the next term, we would have x to the n minus 2, while 8 minus 2 would be 6, and so on. So the values, the exponents for the x's are decreasing as we go from one term to the next. On the other hand, the exponents for the y values are increasing. So starting with y to the 0 power, which would end up being just 1, as our first term. The next term would be y to the first. Then we'd have y to the second, y to the third, and so on. Now, something else that's important to understand is that that exponent for the y and the r value for n choose r are always the same. So when we look at that first term with our coefficient, the r value is 0, our exponent for y is 0. When we look at the next term, our value for r is 1, and our exponent for y is 1. And the next one, it would be n choose 2, and our exponent for y is also 2. So that's also important to understand. And something else you'll see as we work through these is the fact that the exponents always add up to be the degree of our original binomial. So if we had x plus y to the 8th power, as we go through this, the x and the y, those exponents should add up to be 8. So let's take what we're talking about here and apply it now to this example, x plus y to the 4th power. Okay, so looking at this, we have x plus y to the 4th power. So our first coefficient is going to be found by taking, since we have our exponent is 4, it's going to be 4 choose 0. And then we would have our x would also have an exponent of 4 as well. So it would be x to the 4th power. Technically it would be y to the 0 power, but that again is just going to be 1. Now for the next term, we would have 4 choose 1. And our x, again, is going to be descending. It's going to be decreasing as our exponent, rather, is going to be decreasing. So it would be x cubed. Our y is going to increase now to be an exponent of 1. Let's look at the next term. So the next term would be 4 choose 2. And for the coefficient. And your exponent for the x, remember, is decreasing. So this is going to go from 3 now down to 2, so it'll be x squared. Our y exponent is increasing, so it's going to go up to being y squared. Also notice these exponents. The exponents for for this term here are 2 and 2, which add up to be 4. The exponent for the previous term are 3 and 1, which also add up to be 4. So every term, your exponents should add up to be 4 if you're doing it correctly. Let's look at the next term. So the next term, it'll be 4 choose 3, and we would have x being decreased now to being x to the first power, and y, our exponent, is increasing to y cubed. And our last term then would be 4 choose 4, which, and then the x is going to be x to the 0, or just 1, and our y increases to be y to the fourth power. Now we're going to simplify these. Now 4 choose 0, we know from in the previous video, would be 1. So that's going to be 1x to the fourth. 4 choose 1 is 4, so this will be 4x cubed y. 4 choose 2 is 6, that's going to be 6x squared y squared. And 4 choose 3 is 4, so it's going to be 4xy cubed. And lastly, 4 choose 4 is 1, so it'll be 1y to the fourth. Let's talk some more now about these coefficients. 1, 4, 6, 4, and 1. And let's look at Pascal's triangle that we talked about yesterday. And let's look at that fourth row. So we're dealing with x plus y to the fourth power, and the fourth row here, the numbers in that row are 1, 4, 6, 4, and 1. Just so happen to be the coefficients in our polynomial here. So that is another pattern that we can see from Pascal's triangle. This is actually going to be very useful to us, because now instead of having to go through that whole process of doing the 4 choose 0, the 4 choose 1, the 4 choose 2, I can just recognize that, oh, this is the fourth power, so my coefficients are going to be from the fourth row in Pascal's triangle. 1, 4, 6, 4, and 1. So that's going to save us some time. Let's use this binomial theorem to look at this next example. This next example says, find the power of y and the coefficient of the x to the third term in x plus y to the eighth power. So they don't want us to actually expand this out completely. They just want us to figure out what would be the power for the y value and the coefficient when we would have the term with an x cubed. So to set it up, this is what I'm going to look for. This is how I'm going to set it up here to make it a little easier. Now remember, the exponents for each term are going to add up to be the degree. So the degree here is going to be 8. So this 3 is going to add to some other number that's going to equal 8. Well, hopefully you're thinking in your head that that should be 5. So that is correct. Now, the coefficient is going to be 8 choose, since we have 8 as our exponent, or as our degree here. It's going to be 8 choose something. And remember, this exponent for the y is the same as the r value in our coefficient. So it's going to be 8 choose 5. Because remember, like looking at this previous problem, our exponent here of 2 was the same as our value for r here, which is 2. So here our exponent for y was 3, which is same as our r value here for 4 choose 3. So we need to use that exponent here for the y to figure out what the coefficient would be. So the coefficient is going to be 8 choose 5, which if you do that on your calculator, you get 56. So our answer is going to be 56 x cubed y to the fifth. Why don't you guys take a minute and try this next one on your own. There's a typo in there. It should say find the power of y and the coefficient of the x to the fifth term in x plus y to the ninth power. So just like the previous one, I want you guys to work this one out. So pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did. So just like the previous one, we're looking for a coefficient and a power for y. But this time we're looking for x, the term for x to the fifth power. So we're trying to figure out what exponent we'd apply to y here to have where these would total to be 9. So hopefully you got that that would be 4. And then the coefficient is going to be 9 choose 4. x to the fifth y to the fourth power. And 9 choose 4, if you do that on your calculator, is 126. So we have 126 x to the fifth y to the fourth. Now let's look at how we can use that first example that we were looking at earlier in the binomial theorem to expand this, 3w minus 2 to the fourth power. Now remember, I can save myself a lot of work by looking at Pascal's triangle. So again, we're dealing with the fourth power, so we're going to be working with row 4. So I know my coefficients are going to be 1, 4, 6, 4, and 1. So for my first term here, like I said, my coefficient is going to be 1. But then we don't have an x, we have a 3w. So we're going to take that 3w to the fourth power. Our y value is negative 2 to the 0 power, again, is going to be just 1. Then the next term, we would have plus 4. Again, from Pascal's triangle. That's how we know that the next part there, what's in purple there, would be 4. And then the 3w would be cubed. And negative 2, you got to recognize that we're working with the negative 2 here, would be raised to the first power. Let's look at the next term. The next term, again, using Pascal's triangle, we would get that would be 6. The 3w, that's going to be, the exponent is going to be decreasing, so that's going to be squared. And negative 2, that exponent is going to increase to also be squared. And again, double check and make sure your exponents add up to be 4. Let's go to the next term. So again, are going to go to be 4 using the Pascal's triangle. The 3w is going to decrease to just be 3w to the first power, or 3w. And the negative 2, that exponent is going to increase to be negative 2 cubed. And lastly, that term is going to have a coefficient there of 1 from Pascal's triangle. 3w would be to the 0 power, which is just 1. And then negative 2 would increase to be negative 2 to the fourth power. Next, what we're going to do is we're just going to take every parentheses and apply the exponents. So here we would have 1 times 3w to the fourth power. We applied both the 4 to both the 3 and the w. So 3 to the fourth power is 81, and w to the fourth power. Let's go to the next term. The 4 is going to stay the same, for right now at least. The 3, we're going to cube that, so that's going to be 27. We also cube the w, so that'll be w cubed. And the negative 2 will just stay a negative 2. Then the next term, the 6, we won't do anything with that yet. The 3, we're going to square that to get 9, and the w, we square that, so we have 9w squared. Negative 2, you got to remember, this is a negative 2 being squared, so it becomes a positive 4. And then again, the 4 stays the same for right now. The 3w is also going to stay the same for right now. And negative 2 cubed is going to be a negative 8. Let's go to the last term. And so negative 2 to the fourth power would end up being a positive 16. And now what we're going to do is we're going to go through each one of these, and we're going to multiply the numbers together. So here we would have 1 times 81, which would just be 81. So we'd have 81w to the fourth power. For this next term, we're going to multiply the 4, the 27, and the negative 2 together. And so when you do that, you get negative 216 w cubed. For the next one, we're going to take 6 times 9 times 4. And when you do that, you get 216 again times w squared. For the next term, we're going to take the 4 times the 3 times the negative 8, which when you do that gives us negative 96 w. And lastly, 1 times 16 is just 16. So this would be your final answer. So again, even though that seemed like a long process, it's not a hard process. It's just a longer one. And it's a lot easier than taking 3w minus 2 times itself 4 times. Now I want to make sure that you know how to do this, so I want you guys to take about 5 minutes. It'll take about that long for you to be able to expand this one out. So we have 3 minus 4y to the fifth power. Again, to make things easier, use Pascal's triangle. So this time, in Pascal's triangle, we're looking at the fifth row, since we're dealing with the fifth power. So these are the numbers that we would use as our coefficients, the 1, the 5, the 10, the 10, the 5, and the 1. So why don't you guys go ahead, pause the video, and work this one out. And please take the time to do that so you have some practice doing this on your own. And hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did here. Let's start out with figuring out, first look to see do you have the right answer here. So we have 243 minus 1,620y plus 4,320y squared minus 5,760y cubed plus 3,840y to the fourth minus 1,024y to the fifth. So if you did not get that answer, just double check, make sure that you use those right numbers, what I have here in purple from Pascal's triangle. If you double check and if you have those right, make sure that you have the negatives in here. So negative 4y to the first would still be negative 4y. If it's a negative and it's being raised to an even exponent, that should be a positive number, so that should be a positive 16y squared and so on. So double check those. And just double check your math, make sure you have all that correct. Now, to ease your anxiety, this is the hardest part for this lesson. Let's end by looking at some easier examples. Let's look at this one. Here it says a coin is being flipped 5 times. How many of the possible arrangements of heads and tails have at least 2 heads? So again, the fact that we have a coin being flipped 5 times, we want to figure out how many different arrangements we could get with at least 2 heads. So to start out with, we would have 5 choose 2, because that would be getting exactly 2 heads. We could also have 5 choose 3, because that would be having 3 heads. 5 choose 4, or 5 choose 5. And 5 choose 2, that would end up being 10. 5 choose 3 is also 10. 5 choose 4 is 5, and 5 choose 5 would be 1. And to find the total possible arrangements, then we would just add these together and get 26. So it would be a total of 26 possible arrangements here. We would have at least 2 heads if we flipped a coin 5 times. Let's look at another example that uses, again, this binomial theorem. It says, find all terms in h plus t to the 5th power in which the power of h is at least 2. Well, we could start out with, then, at least having h squared. That has a power of 2. We could have h cubed, we could have h to the 4th, or all the way up to h to the 5th power. But now let's take and figure out, well, what values, or what would our exponents be for the t's? Remember, they have to total to be 5. So you could have t cubed for that first one, because then they would total 5. For the next one, the t would have to be squared. For the next one, the t would have to be to the 1st power, and for the last one, you would not have a t at all, or t to the 0 power. But now we can use those exponents for the t's to figure out what our coefficients are going to be. Now again, it's going to be, since n is 5, it's going to be 5 choose something. And since my exponent for the t is 3, it's going to be 5 choose 3. For the next one, it'll be 5 choose, and since the exponent for the t is 2, it'll be 5 choose 2. And for the next one, then it'll be 5 choose 1, and the last one will be 5 choose 0. Well, 5 choose 3 is 10, 5 choose 2 is also 10, 5 choose 1 is 5, and 5 choose 0 is 1. So those are all of the terms where we have an exponent for h of being at least 2. So that's it. That is how we use the binomial theorem. Again, that part where we were expanding out a binomial using that theorem is the most challenging part to this lesson. But hopefully you were able to handle that on your own. So good luck now as you work on your assignment.